So, good evening, everyone. So, for today, I have solved a question of stack, and previously we have completed the trapping rainwater problem and NAC and PAC problem, means next greater element and previous smaller element. So, we will be utilizing those concepts in this question also and moving forward to our journey. So, our question is sum of sub-array minimum. So what the problem statement says, in this problem we have given a array, and we have to find the number of sub arrays, and we have to basically find the minimum element of each sub array, and eventually adding all the minimum elements of every sub array, and adding them and return them in our answer. So this is the problem statement. So suppose we have a example of 3 1 2 4. These are the elements of our array. So their sub array will be 3 3 1 3 1 2 and 3 1 2 4. Now moving forward, 1 1 2 1 2 4, and now moving forward 2 2 4, and lastly 4. So these are all the sub arrays that are possible of this given array. So our question is to get the minimum element of each of sub array. So for the first sub array, 3 will be the minimum. From second onwards, 1 will be the minimum till 1 to 4, and after then 2 will be the minimum for 2 and 2 comma 4 sub array, and lastly 4 will be the minimum. So adding all the minimum values, we will get the 17 as the answer. So this is the problem statement. So for the brute force, clearly we can answer that firstly we will getting all the subarray, and for each and every subarray we will be calculating their minimum element, and updating our minimum and adding that minimum element in our sum value. So for the brute force, our code will be run as we will be running loop from 0 to n minus 1 for the I. For the j, we will be running loop from I to n minus 1, and our minimum value will be the minimum of our mini comma array of j, where mini will be nothing but array of I initially. So whichever will be the smaller, that will be our mini as the minimum element of that subarray, and in the end we will be adding sum equals to sum plus mini, and in the end we will return the sum. So that's how we will able to solve this problem. So here the time complexity will be reached to big O of n square, because we are running two loops, and thus our complexity is high, and while space complexity we have no extra space usage, so we go off one. So this is not the good solution. We can optimize it up to big O of n solution of complexity. So for that, our question, firstly we have to understand something like finding the individual contribution of element, eventually adding them to get answer. What does this statement means every element. Let's suppose this given example 3 1 2 4. So 3 was minimum element for one time, while 1 was the minimum element for 6 subarrays, and 2 was minimum for 2, and 4 was minimum for the one time of subarray. So overall these were nothing but number of times the element that given was minimum in their subarray. So for the answer, we will be just adding them and getting our correct answer. Like 3 was minimum for one time, so 1 into 3 equals 3, plus 1 was 6 times, so 1 into 6, and that's how number of times the element have come as minimum element multiplied by that minimum element, and eventually adding this value with the next element up to the end, all elements will be executed, and our answer will be returned. So we will be using this approach where we have to find the next smaller element and previous smaller element. Suppose we are standing at x point and elements are there on their left hand side and right hand side as well. So our task will be to calculate the next smaller element when we encounter our next smaller element. So we have noticed that the number of elements that can be the combination or can be the sub array of our given array, which with that x value as minimum element had already confirmed for the right hand side. And similarly we will be check for an PSE, previous smaller element. So that will be calculated for the our left hand side, and the number of times the element have encountered as the smaller element multiplied by that element plus next element same conditions up to the end, and adding all those in our sum and returning the answer. So this will be the approach we will be following. So there are some edge cases that we will discuss in further after pseudocode. So let's come to the pseudocode. So for the pseudocode we have given a int sum array. Now we will be calculating the next smaller element by making a function as find an SE, in which we will pass this current array. And similarly for the PSE, means previous smaller element, for this uh, uh, find PSE array, make the function, and given the total as 0 equals to 0, as we have currently no element. And we will be running the loop from 0 to n minus 1, and in this our left side will be I minus PSE of I. Means what are left and right? So left and right are nothing but number of times the element have made the subarray. So if we are standing at x, so number of element or number of subarray that our x element has encountered as minimum element for those array subarray. So they can be calculated as left, and we can get them by using I minus PSE of I. So here why I minus PSE of I? So PSE is previous smaller element, means the element which is previously the which is on the left hand side, and that is smaller than our current element or x element. So we will not take that element. So eventually we are just subtracting our current index minus previous smaller elements index, and with this we are able to get number of our subarray on left hand side. And similarly for right hand side, next smaller element minus I, because NSE is on right hand side and NSE will be greater. So it will index will be NSE's index will be greater. So NSE's index minus our current index x, and we will eventually get our right combination of subarray. And for the total, nothing, just add total plus right multiply by left multiply by our array I, and so that's how we are able to get number of times that x will encountered for those subarray as minimum element. So with this formula we are able to calculate that, and in the end we will return our total. So for the find next smaller element and previous smaller element, our function pseudocode, firstly we have to analyze the edge cases that I have discussed. So the edge cases, like if we have given an array of 1 comma 1, so in this case our NSE will be 1 and 1 comma 1, two cases, while the PSE will be 1 and 1 comma 1. So here we are seeing that 1 comma 1 are encountering two times, although it has already counted. So for the our PSE, we have to check the condition for previous smaller element and equal element. If it is the case, so we will be checking for them. So that's the edge case. And now comes to the functions code of PSE and NSE. So for the NSE part, our loop will be run from n to our 0. So n minus 1 to 0 our loop will run, and we will be checking if our stack is empty or is there any case of arrays stack dot top element is greater than or equals to array of 5. So we are finding the next smaller element. So our element should be smaller. So if element is greater or equal, we will just pop it out. And if it is not the case, so we will check is our stack is empty. If it is empty, then return n, and if it is not empty, then return stack dot top element. And in the end, we will be pushing stack dot push of that index I, because we need the index I, not the element. And after this, we will be returning the NSE. And for the PAC or PSEE, because it's previous smaller and equal elements, two conditions are there. So we will be taking a PSEE of array and a stack and run the loop from 0 to n minus 1, where we will be checking that if is our stack is empty or our array's stack dot top element is strictly greater than array of 5. That means our stack's element is greater and not equal. Just mentioning it because that's the edge case. So it should be strictly greater than our current element. If it is the case, then if it is the case, means it is greater. It's if it will be equal, we should count it. But because it is greater, we have to pop them all out, and only we will consider them if they are greater, if they are smaller or equal elements for the PSEE. So we will be popping out these elements, and now our PSE of I will be checking if a stack is empty. So we will be pushing -1, else our stack dot top element will be as PSE of I. So in the end, we will be pushing the index I and returning our PSE. So that's how we will be able to solve this problem. While the complexity, for the time complexity, our time complexity will reach to big of 5n, because big of 2n for NSE and big of 2n for PSE we have discussed earlier in our previous videos, and big of n for the traversal. So overall of space time complexity is big of 5n, while the space complexity is big of 5n, because we are utilizing extra space of stack and array. So this is somehow optimized solution, and that's the question that I did. Hope you like this video and understand the concept of NSE, PSE and why they are important. And not only that, but also understand the sub-array multiplication, basic mathematics sub questions. And with this, this video ends, and we will be meeting in our next video.